In problem number 8, Takashi spent a third of his money on a jacket. He spent a fourth of the remaining money on a pair of boots. And if the pair of boots cost $35 less than the jacket, how much money did he have in the beginning? So let's take his money first of all and break it down into 3 equal parts. So a third of the money went to the jacket. So if he used 1/3, there's 2/3 left over, and 1/4 of the remaining money was spent on a pair of boots. So we're going to take those two and we need to break them down into 4. So we split each of them in half, and 1/4 of the remaining money was spent on a pair of boots. So if you notice, the jacket really cost 1/3, whereas the boots were a half of a third. Another way of saying that is that the jacket cost twice as much as the boots. So since the boots cost $35 less than the jacket, then we should say that the boots plus $35 equals the jacket. And since the jacket is 1/3, then the boots plus whatever's left over in that third should equal the same as the jacket. So what this is saying is that a half of a third is $35. Or in other words, a third is $70. So you can see that the boots are $35 and they are $35 less than the jacket that was $70. So what we end up having here is either 3 times 70 or 6 times 35 for a total of $210 at the beginning. So this would be a non-algebraic way of going about doing this. Algebraically, we would start with what we're trying to figure out, which is how much money he had at the beginning. And we let x be the amount of Takashi's money at the beginning. Then a third of x is the amount spent on the jacket. There's 2/3 left over, and so we want a quarter of 2/3 of x. Yeah, well, this is a little bit difficult, so what I'm going to do instead is this. Say a third of his money he spent on the jacket. So I'm going to say a third of x is j. Then a quarter of the remaining money, so a quarter of 2/3 of x equals b. And another way of doing that would be 2/12 or 1/6 of x equals b. And finally we have the relationship that the boots are $35 less than the jacket. So if you take off $35 from the cost of the jacket, you would have the amount of the boots. So what we can do with this is just substitute the values using x in place of j and in place of b. So we'd have 1/3 x, which is j, minus 35, and that's equal to 1/6 x. I'm going to subtract 1/6 x from both sides and add 35 to both sides. So a third is really 2/6, and 2/6 x minus 1/6 x is 1/6 x, and that's $35. And that's what we found above using the diagram, that 1/6, we took the thirds and we broke each third into a half, and so each half is 1/6, and 1/6 is $35. We would multiply by 6, and 6 times 35 is $210. So that's a way of doing that. Again, that's not trivial, but and it took me a minute to think about how to set that up, but that's the way that I would go about doing that.